Okay, I hope I'm audible to all students who are attending this particular practice lecture for the introductory macroeconomics course. In this particular practice lecture, I'm going to solve a couple of numericals based on the concept of IS and LM curves, which I have covered up in my lectures on Keynesian economy. So this lecture is going to be helpful for all those students who have either taken up an introductory course in macroeconomics or even an intermediate course in macroeconomics. So this is a common lecture for introductory macroeconomics as well as intermediate macroeconomics course. So let's quickly start with this particular practice lecture on IS and LM. Okay, so let's quickly look at practice problems on ISLM. All students attending this lecture can write the heading practice problems on ISLM curves. So let's look at the practice question in this lecture. Consider the following ISLM model. Consider the following ISLM model where we are given that the consumption function is 200 plus 0.25 YD, where we all know that YD denotes disposable income. YD denotes disposable income. Okay, C denotes consumption. We all know that consumption is a function of disposable income. Disposable income is the income left after paying taxes to the government. Okay, investment function is given by I is equal to 150 plus 0.25 Y minus 1000 I. You can clearly see that investment and interest rates share a negative relationship because higher the interest rates, higher the cost of borrowing the firms are going to face, so they will lower their investments. Because when interest rates go up, the cost of borrowing funds from the banks go up. So firms would be reluctant to borrow less. As a result, they will lower their investment. So you can clearly see that interest rates and investment share a negative relationship. They are given the government expenditure is constant and equal to 250. They are given that the tax in the economy is 200. And we are also given that the demand for real money balances. M by PD denotes the demand for real money balances. This is 2I minus 8000 I. You can clearly see that demand for real money balances is positively related to income because higher the income, higher the demand for money to buy goods and services. Demand for real money balances is negatively related to interest rates because higher the interest rates, bonds would be more attractive, money would be less attractive. So demand for real money balances goes down when interest rates go up. And then we have the money supply M by P, which is equal to 16. Okay. So I am making quickly all students write just for clarity. G denotes government expenditure, so that there is no confusion. All students can write this. T denotes the taxes paid to the government. Okay. M by PD is the demand for real money balances. And if I just talk about M by P, that's the supply of real money balances. Okay, so we are clear with all the terminologies. Now the first part to the question asks us, derive the IS relation. So let's quickly solve this. First of all, I'm just revising with all students. You must have gone through my lectures on Keynesian economy and ISLM. What does the IS curve denote? So I'm just writing it. The IS curve shows combinations of output and interest rates such that the goods market is in equilibrium. Such that the goods market is in equilibrium. That is, when will the goods market be in equilibrium? Goods market will be in equilibrium when my aggregate demand is exactly equal to the output, which is nothing but demand coming from the households plus demand by the firms plus demand by the governments. In this numerical, students can see that there is no open economy. There are no exports and imports, so I'm ignoring that. The goods market will be in equilibrium when the output is exactly equal to the actual aggregate demand. You can also think of Y as the planned output and AD is the actual aggregate demand. So in the economy, when I produce that output which is exactly equal to my actual aggregate demand, where actual aggregate demand is the demand coming from the households in the form of consumption, demand from the firms in the form of investment, demand from the government in the form of government expenditure. So my goods market will be in equilibrium when Y is equal to C plus I plus G. So IS curve is going to give us combinations of output and interest rates such that my goods market is in equilibrium. So now we need to find the equation of the IS curve. So what we are going to do is we are going to substitute C, I and G from the equations given to us. So what we can do is if I erase certain portions of, let's now look into the math of this. So I can write that aggregate demand. So I can write Y is equal to C plus I plus G, which implies Y is equal to, what is C? C is 200 plus 0.25 YD. Now, students can also note that disposable income is the income left after paying taxes. So Y minus T. YD is equal to Y minus T. My disposable income is the income minus the taxes I pay. So it's going to be C, which is 200 plus 0.25. Instead of YD, I can write Y minus T. Plus I is this. So I can sub in the value 150 plus 0.25 Y minus 1000 I plus G is how much? 250. So I have substituted all the values. This whole thing is my C, this is my I, this is my G. And now what we are going to do is we are going to solve this equation and write Y in terms of I. So let's quickly start solving this. So let me erase now this part off because students by now should be comfortable with the symbols they have written. So I'm going to use this page to do the math. So Y is equal to, now let me open up this whole equation. So 200 plus 0.25 Y minus 0.25 into T. But how much is T, guys? T is 200. So how much is 0.25 into 200? If I quickly calculate this, it comes out as 50. It comes out as 50. So minus 50. 0.25 into T is going to be, T is 200. So 0.25 times 200 is going to be 50. Okay. So, and then I can further write. So then it's going to be plus 150 plus 0.25 Y minus 1000 I plus 250. So see, I have opened up the brackets and I have written the whole equation for Y. So Now let's add up all the constant terms. So 200 minus 50 is 150. 150 plus 150, 300. 300 plus 250, 550. 0.25y plus 0.25y will be 0.5y. And then I also have minus 1000. And now what I'm going to do is I'm going to bring this to the left hand side. So it's going to be y minus 0.5y is equal to 550 minus 1000i. So this implies y minus 0.5y is 0.5y is equal to 550 minus 1000i. So my y is going to be 550 minus 1000i over 0.5, which I can also write like this. So if I erase all this off, I can write that y is going to be 550 minus 1000i over 0.5. I can write as 5 times 10. 5 cancels with 10, making it 2 here. 2 into 550 is going to be 1100. 2 into 1000 is going to be 2000 with a minus. So I can say, therefore, the equation of the IS is y is equal to 1100 minus 2000i. This is my equation of the IS. So hoping all students have understood how we have derived the equation of the IS curve. Okay, and now let me erase some portion off and let's look at what part B is asking. So if I erase all this off, I can write here part B. Now let's look at part B. Part B is derive the LM relation. So what I'm doing is I'm erasing all this off now. And on the right hand side, I'm just writing the IS equation again for perfect clarity. The IS curve I've got has come out as y is equal to 1100 minus 2000i. I erase all this off also. Now students, let's first of all understand and revise what's the LM curve. So the LM curve shows combinations of output and interest rates such that the money market is in equilibrium. Such that the money market is in equilibrium. And when is the money market in equilibrium? That is, I can write supply of, I can write demand for real money balances. I can write the money market is in equilibrium when demand for real money balances, which is M by PD, is equal to supply of real money balances. Supply of real money balances is captured by M by. So I'm revising it again with all students. The LM curve is going to give us combinations of output and interest rates such that the money market is in equilibrium. The money market is in equilibrium when demand for real money balances equals supply of real money balances. So mathematically, if I do the working for LM here, M by PD equal to M by P. M by PD is the demand for real money balances. M by P is the supply of real money balances. How much is M by PD? 2y minus 8000i. And how much is m by p? 1600. So if I solve this further, it's going to be, again, let's solve this for y. So 2y is going to be 1600 plus 8000i. I take minus 8000 to this side. Very simple. And then what will y be? 1600 plus 8000i divided by 2. I can further simplify it. 1600 divided by 2, 800. 8000 divided by 2, 4000. This is my equation of the LM. So we have finally got the equation of the LM curve, which is y is equal to 800. Y is equal to 800 plus 4000i. Okay, so now what we are going to do is, let us see what the next point in this particular question is asking us. So if I erase some portions off, so erasing all this off, so I'm also erasing this particular portion off, and I'm writing here the equation of the LM curve. So my LM equation has come out as y is equal to 800 plus 4000i. Now part C asks us, solve for the equilibrium real output. And the equilibrium interest rate. Solve for the equilibrium real output and the equilibrium interest rate. So what the next part asks us. So I need to find out y star and I star basically. Real output, equilibrium real output is y star and equilibrium interest rate is I star. So basically, how do I do this, guys? I solve these two equations simultaneously. That means the output from the IS and the output from the LM should exactly be equal to each other. Remember, the market is in equilibrium when the IS and the LM curves intersect each other. At the point of intersection of the IS and the LM curve, recall both the goods market and the money market are in equilibrium. When IS and LM curves intersect each other, both the goods market and the money market are in equilibrium. So how do I solve for equilibrium y star and I star? The y from the IS should exactly be equal to the y from the LM. So I can write output from the IS should exactly be equal to output from the LM, which implies, what is my output equation from the IS? 1100 minus 2000i. What is my output equation from the LM? 800 plus 4000i. Let's solve this. I take 800 to this side, 1100 minus 800, and I take minus 2000 to this side. So 4000i plus 2000i. So what do I get? So if I erase this particular portion off, let me do the remaining algebra here. Due to lack of space, I can do it here. So 1100 minus 800 is 300 is equal to 4000i plus 2000i is 6000i. What is my I star? 300 over 6000, which is nothing but 3 by 60. 3 by 60 is 1 by 20. And then students can calculate 1 by 20 and verify that if you look at 1 over 20, you can check this out using your calculators also. It comes out as 0.05. So my I star is 0.05, or in percentage terms, 5%. My I star is 0.05 or 5%. And now I can put this value of I in either the IS curve or the LM curve. So let's put in the IS curve. You can put in the LM curve also if you want. So if I erase this part off, I can write putting I star equal to 0.05 in either the IS or the LM. Okay, so I put in the IS curve. So Y star is going to be 1100 minus 2000 I star. Put in the value of I star, guys. I star is 0.05. This is going to be 1100 minus 100, which is 1000. So my Y star has come out as 1000. Students can verify this. My equilibrium interest rate has come out as 5%. My equilibrium output has come out as 1000. So hoping all students have understood this. And then the last part asks us to draw the IS and the LM curve. So if I erase part C, the question now asks us to draw. So part E is draw the IS. This is part D. Let me correct myself. Part D, draw the IS and LM. So we already have the equations. We can quickly draw them. Erasing this part off. Erasing this part off as well. I'm just quickly writing that the I star has come out as 5% and Y star has come out as 1000. Let's plot the IS. Now the IS is given by the equation Y is equal to 1100 minus 2000 I. Let's take values. When I is 0, Y will be 1100. And when Y is 0, what will I be? When Y is 0, it's going to be, I is going to be 1100 divided by 2000, which is 0.55. So we are calculating the intercept basically. When I put I as 0, Y is 1100, put Y as 0 and solve for I comes out as 0.5. Similarly, for the LM curve, Y is equal to 800 plus 4000 I. Again, let's take values. When I is 0, Y is 800. When Y is 0, what will I be? When Y is 0, I is going to be minus 800 by 4000. So it comes out as minus 0.2. So let's draw the diagram quickly once we have found the intercepts for the IS and LM. So on this is origin. On the horizontal axis we have output. On the vertical axis we have interest rates. I use black color for the IS. When I is 0, Y is 1100. When I is 0, Y is 1100. And when Y is 0, I is 0.55. When Y is 0, I is 0.55. So this is going to be my IS. And for LM, I use the red color. When I is 0, Y is 800. So when interest rates are 0, output is 800. Okay, and you can clearly see when Y. So I don't need to plot that. From here only I can make an upward sloping LM curve because I know that my LM curve is upward sloping. So the black is my IS. Okay, the red is my LM. The intersection gives us 1000 as Y star, and 0.05, which is 5% as my interest rate. So this is my diagram. So this is where I stop in this lecture.